Hi, I'm Lingfan Gao, Senior Software Engineer at Microsoft working on Fluent UI, and this is another episode of Fluent UI Trainings. Let's talk about slots. You've probably heard about slots from earlier Fluent UI training videos. Slots are essentially an API mechanism in Fluent UI to let developers have access to every single part of the underlying HTML markup. Let's teach you some tips and tricks to customize slots to the max. Let's take a look at slot longhands. In previous videos, you've probably seen that you can put a JSX element inside a slot and render it inside the slot. But we can go further. In this example here, we're using a message bar. The message bar has an icon slot. Let's remove this icon slot customization first and see what happens. You can see here that the default icon that's rendered for a message bar with the intent success is a green check mark. This is just an API contract of the component. This icon is rendered automatically. But if we want to change this slot, we can use the icon slot. And in this case, these property key values inside of the JavaScript object roughly correspond to JSX attributes. We're trying to represent a JSX element using a JavaScript object, essentially. And in this longhand, we decided to use a custom class name. And this class name is simply a style override that sets the color to red, and we also set the cursor to be a pointer when we hover over the icon. The children is what would render inside the slot. And normally this would just be, if you didn't have any other customizations, you'd put the send regular JSX element inside the icon without an object. But because we want to customize extra properties, we have this children. We also have an on-click handler here, which basically just, opens up an alert once we click the icon. So let's take a look at the example here. You can see that our icon is still rendered inside the FUI message bar icon slot. We can hover over it, the pointer is there, and if we click on it, we trigger an alert. Simple. But what if we don't want the slot to appear at all? This brings us to the topic of disabling slots. So to keep things consistent, we're still using the message bar component. So similarly, if we remove the slot override, you can see that the default icon is going to be a green check mark. But what if we don't want this icon to render at all? We still want to keep every other part of this component. Simple. We can just set the slot to be null. Once we set the slot to be null, you can actually see that the slot doesn't render at all. You can't see FUI-message bar icon anymore. Let's remove the override again. You can see that the icon now renders under FUI message bar icon. So simply by setting null, we can control the presence of the slot. You can completely remove slots that you don't want, but on the similar end, like previously, you can customize those slots to be whatever you want. There's another prop we have called the as prop. So the as prop is just a prop that's a string, essentially, and it represents the name of the underlying HTML element that you want to render the slot as. This prop isn't as useful, but it is useful in certain situations. It's not a complete free field prop. You can't make this render, for example, a span. Fluent UI gives a contract of what different as props you can use for a component. And in this case, we use a button, and we render the button as an anchor tag. This is a fairly common pattern in the web. We want to render an anchor button. So if we look at the DevTools here, you can see that our FUI button is rendered as an anchor tag instead of a semantic button element, but it still has the same look and feel as any other button component. So children render functions are the ultimate bailout for anything related to slot rendering. We're using the message bar as an example again, with our favorite icon slot. You can see that the children property of the longhand is no longer a JSX element, it's actually a function. And this function has two arguments. The first one is called component. This is the component that the slot would have rendered as originally. And the second argument is props, which is the props for that component. So if we remove our composition here, you can actually just render the exact same thing that would have rendered previously just by using the function to render component and spreading props inside. But in this case, we've composed this slot, and we decide to wrap this entire slot around a semantic button element. Now, if we look at the DevTools, we can see that inside our message bar, we no longer just render the FUI message bar icon slot, but we render the button first. So what we see here, this component, is actually the entire slot. It's not the children of the slot, it's not what gets rendered inside the slot, it is the slot. That's why if you use the children render function, you can really change anything about this. There's no real obligation to actually use component or props. You can leave those arguments empty in your children render function and render something completely different if you want to. So let's move on to our next topic, which is positioning. What do we mean by positioning here? Positioning in Fluent UI refers to any components that have detached or floating surfaces. So these components can be the menu, the popover, or the combo box. There are lots of aspects of these position surfaces because, they can kind of appear at anywhere, and they're not really bound by the layout of the content underneath it. So the good news is that configuring these position surfaces is consistent throughout the entire library, and all the components share the same positioning configuration API. But what does that mean? So very simply, you can configure the positioning through a string, right? This is what we call the positioning shorthand. It's a string that includes a position and an alignment separated by a dash. And every single component that supports positioning will have a prop. And this prop is actually called positioning, right? And in this example, I've just kind of put together the exhaustive position alignment combinations that you can have. So let's start with above start. So above means that the container is actually placed above the target element. And the target element in this case is a button. And the alignment is start, which means that you align the bounding boxes, right? The edges of the bounding boxes. So in this case, it's the left-hand side edge. And if we move clockwise around, you'll see that a position without an alignment just means center aligned. And you can also have an end alignment, which means it's rendered above, but also aligned to the end edge of the bounding box. So for vertical positions, we have above and we have below, and the alignments can be start or end. For the horizontal positions, we have before and after, and the alignment can be top or bottom, which corresponds to the top and bottom edges of both bounding boxes. The reason we went for this kind of naming scheme that's called start, end, after, or before is because we want to support right to left applications a lot easier. So Fluent UI will actually automatically flip the positioning for right to left scenarios automatically based on your position. So if this was a right to left application, after would actually be flipped and would actually appear on the left-hand side of the bounding box. So this is the simplest way of configuring positioning. This is this simple string configuration for a positioning prop. And we have a lot of other positioning options. We're probably not even going to go through all of them in this session, but just to show you what kind of that looks like, we call this the longhand. So the terminology here, we use longhand. It's similar to what we talked about earlier about slot longhands. Instead of using a string configuration for the positioning prop here, we actually use a JavaScript object. So just to translate the previous string values, you can see above start as the string value, but in the longhand, we now have a property called position and a property called align. And here we just use above start for both those values. So this example here does the exact same thing as the previous one, but translates everything to this longhand positioning syntax, which is a JavaScript object. We can put a lot of more things in there. So simply, we have an offset. What is an offset? So you can define an offset for the positioning axes of the target. And this is known as the main axis and the cross axis. So simply put, you can consider the main axis to be related to the position property and the cross axis to be related to the alignment. So the offset can either be a single number, it can also be a JavaScript object, or it can be a function. Let's take a look at the examples we can have. So we have two buttons here that both open popovers. The difference here is that the first one uses an offset configuration, which is a JavaScript object. So the JavaScript object contains the cross axis and the main axis, and these are numbers that correspond to what's inside these input fields. So let's, for example, change the main axis alignment to be 50 pixels. So once I open it, you can see now that the position of this component is actually position after, so it's positioned to the right of this button in this case. And because it's positioned to the right, the main axis is horizontal. So 50 pixels means that the container is shifted 50 pixels away from this button. But the main axis offset can also be negative. So if we make this negative 10 pixels, you'll see that it now shifts in. So if I increase the negative axis even more, you'll see that slowly it moves into the target button. So let's set this back to 10 pixels like we had originally. The cross-axis offset represents the alignment. So in this case, the position doesn't have a corresponding align property in here, which means that by default it's centered aligned. So let's set this cross-axis alignment to be 0. You'll see here that the container is centered aligned to this button. So if we increase this cross-axis alignment, let's see, say this offset will be 50 pixels, you'll see this now shifted vertically along 50 pixels. And again, you can also use negative values for this offset, like all offsets, and it'll be shifted in the opposite direction. The second example is exactly the same, practically, but in the code, instead of using a JavaScript object, we actually use a function. So the function, that's kind of a factory function, and in the simplest form, it returns an object that's essentially the same as the offset that we saw earlier here on line 35. Now, why is this function useful? Let's take a look. So we have the simplest form here, but let's say this offset function takes an argument, which is an object. Inside this object, you can use different properties. So position and alignment. In this case, position and alignment just mean the before-after values or the above-below values that you used earlier. And then you have these rect properties there, right? So position rect means the actual dimension rectangle of the container, and the target rect is the same thing, but for the target button instead. So let's quite simply use a position to determine the offset here. So I'm going to use the position inside this function, and I'm going to say that if the position is after, which is what we currently have, let's return our offsets. So cross-axis offset and the main axis offset. But in all other cases, we actually want to return something else. So this is a bit of a contrived example, but it's just to show you what you can do with this. So let's return instead a hard-coded offset. So let's use cross-axis of 50 and use a main axis of 50. So let's open the second popover. You'll see here that this is essentially the one using the offset function. So now let's set everything to 0, which means that there's no offsets at all. You'll see that this positions that you would expect to normally. But then if we change the position of the second example, right now we have position after, let's change it to below. You'll see now that this is rendered below this target button. And now you'll see that the offset is now this hard-coded offset we set earlier. So based on different positions, you can actually have different sets of offsets, essentially. And you don't even have to stop there. You can also use the alignment as well, but also the rectangles to make sure that the offsets are finely tuned based on the dimensions of your elements. So let's look at another customization, which will be the target. So in most cases, you'll see, for example, in the popover here, that we have what's called a popover trigger. And by default, the popover will position the popover surface on its trigger. What happens if we don't want that to be the case? So here we have our positioning property. You'll see that there's another property here called the target. And the target here in this case is actually HTML element. And we set this HTML element using a useState callback ref, right? So the button here, we render a second button called target. We use a ref and we apply a set target ref there. And once we open this popover, if I click on the popover, you can see that the popover now anchors to the target button instead of the original button that's inside the trigger. So this is pretty interesting because you have the same state control of the original button. So you don't have to, do any extra work to make sure that the popover opens or closes. all you do is change where this popover is aligned. But there's a drawback to this, right? Because you have to use a set target state callback, which means that just to get a handle of this like HTML element, you have to force a re-render, which might not be great in terms of performance, depending on your scenario. So we have another API for setting custom targets. And this is called the imperative API for positioning. What's the imperative API for positioning? So every positioning longhand has a property called the positioning ref. And the positioning ref is a imperative handle. This imperative handle contains functions you can use to, do certain things with the positions, such as setting the target or updating the position. In this case, we care about setting the target. So this example is pretty fun, right? We have a mouse cursor, and as soon as we move the mouse cursor inside this dotted red dash box, you'll see that the tooltip follows the mouse position. If we followed our earlier example and try to, use state every time, it can be pretty expensive, right? Because every time we move the mouse, we don't want to re-render the entire component. So in this case, we have a mouse move callback to help us, track the movements of the mouse. But also we have our positioning ref, and this is called set target. So the positioning logic in Fluent UI is completely separate from the React lifecycle. So once you do a position update there, it doesn't actually result in a re-render. Sometimes a re-render can cause a position update, but they're not coupled. And in this case, we decided to use what's called a virtual element. So this is just a virtual bounding box. We set the XY values based on the cursor position. And then we also set the width and the height to be, 0, so it's just one single point. So there, by doing this, we can actually do all of this behavior without any re-renders in React at all. And if you want to, follow the case earlier where we decided to use a custom HTML element target, you can simply just use a normal ref and then set the target inside a React effect. Now there's a concept of what we call boundaries. So a boundary is let's say where the floating element thinks it should be within bounds. So in Fluent UI, we by default assume that all surfaces are positioned with respect to the browser window as the boundary. And there's like two different kinds of boundaries here. So the first one is called the overflow boundary. Let's take a look at how that works. So if we look at this code example here, the overflow boundary is, let's go to our simple example, which uses a useState callback, and we assign this boundary ref to a div. And this div here is this kind of dotted red line dashed element. We have two examples of popovers here. The first one is positioned below, right on top here, which means that our popover should be positioned below this button, and the alignment is start, which means that the left-hand side edge should align for both rects. And the second example uses position above, so the popover will render above this button, but with the same alignment, right? So we also use the left-hand side edge alignment. The difference between these two examples mainly is the use of the overflow boundary property. This is another property inside our positioning longhand. The first example uses the boundary ref, which is this div with a dotted red line, and the second example doesn't use a boundary ref at all. So let's open both popovers. So let's take a while to understand what's happening here, right? So the first one should have rendered below, that's fine, but the alignment should have been start, which means that the left-hand edges should have been aligned with the button and the popover. This isn't the case. Why? It's because we used our overflow boundary, which is the dotted red line. The dotted red line pushes this popover slightly to the left outside of its intended alignment so that the popover stays within the boundary. In the second case, the alignment's respected because we didn't use a boundary. Here, the boundary is expected to be the browser window, right? So it'll happily overflow this dotted red line, and it'll keep the original intended alignment. So the second boundary we have is called the flip boundary. This is a bit more magical. So flip boundary means that if there's not enough space for a certain position, our positioning logic will actually flip the position. So it's probably best to explain this with an example. So we have a similar example there. We have the same dotted red line that serves as our boundary, and we set it using this boundary ref callback. In the first example, we use position above align start. So our popover should position above this button and also align with the left-hand side edge. The second one, we actually position below, but also aligning to the same place. But the main difference is that we're using this dotted red dash div as the flip boundary. So let's open both popovers. See what happens here. The first popover should have been positioned above, but it's not because we use the flip boundary. So the flip boundary here will actually make the position flip to below because it can tell that this popover isn't going to fit otherwise. But in the second example, we don't have a flip boundary, so it will happily position below, and there's no real need to flip above. But if we actually use the flip boundary on the second example, we can probably see quite easily that it'll start flipping above. It'll change the position. So using these two boundary configuration properties, you can actually make sure that different floating surfaces stay within different parts of the app. And this can be quite powerful for, you know, certain tooltips or certain popovers that you only want to be in one section of the page. That's it for this episode of Fluent UI Trainings. We hope you have more tools in your toolbox for successful web development with Fluent UI, and we'll see you in the next episode.